Surfactants have long been a challenge in wastewater treatment, STPs, and industrial cleaning processes. Surfactants are amphiphilic molecules, which means they have a water-loving head and a water-hating tail. They coat oils, fats, and grease, forming a stable barrier that's extremely hard to break down and remove. Now meet nanobubbles. They're over 10,000 times smaller than fine bubbles, and thanks to their size, they exhibit unique and powerful properties. Nanobubbles have a very high surface-to-volume ratio. Their surfaces are hydrophobic and charged, attracting other hydrophobic materials like surfactants, oils, and grease. They are neutrally buoyant, so they don't rise and burst like larger bubbles. They have a high internal pressure. Due to the unique surface properties, nanobubbles act like molecular traps, attracting and accumulating surfactant molecules on their shell through hydrophobic and electrostatic interactions. When nanobubbles collapse, they release over 400 psi of internal pressure. This effect breaks apart the surfactants at a molecular level, altering the properties of fats, oils, and grease, and making them easier to remove. This is how nanobubbles break surfactants for a cleaner, smarter tomorrow.